Okay, this is problem number 9 on chapter 8, section 1. In this problem, we have the test statistic of 2.56, and that is obtained when testing the claim that the p-value is different than 0.4549. Okay, and well, the first part we need to identify the hypothesis test, the type of test we have. If you have a two-tail, left tail, or right tail, and since the claim contains the mathematical statement of different, we know that we have to use a two-tail test, which means I have to shade this part of the distribution and this part of the distribution, okay? And this is this mathematical statement goes on the alternative hypothesis, okay? Remember, the null hypothesis contains only equality as a mathematical symbol, and the alternative hypothesis contains either this symbol greater than, less than, or different. In this particular case, is different. So the claim is here. So up to this point, since we have a test statistic of 2.56, that is the z-score we use here, 2.56, and here, negative 2.56. Remember, the center of this number line is 0, where the mean is located at 1, the first standard deviation. Negative 1 is 1 standard deviation below the mean, and that's the number 2. Negative 2 here. That's negative 2, and this is negative 2.56. Okay, and this is positive 2.56. So to find the p-value, this is part B. After we determine that it's a two-tailed test, to find the p-value, we need to use find the area, this area plus this area. This is the definition of the p-value. Okay, so following that definition, I will open my calculator. Let me reset my calculator real quick. So we go to second, bars, and we use normal CDF. And if you have this value of the lower limit, we might keep it like this, or we might choose any negative huge number, like I use negative 10,000. If you want to use that one, is fine. Upper value in this case is negative 2.56. Negative 2.56. The mean of this distribution is 0. The standard deviation is 1 because it's the standard normal distribution. So we paste this on the main screen, and we obtain this number. So this area is the value of this shaded area, shaded part of this curve, and you want this area plus this other area. That's why we multiply this by 2. Since the distribution is symmetrical, the area on this side is exactly the area on this side. So this is my p-value, 0.010. That's what we have. We have that here, p-value. Okay. So the next step is choose the correct conclusion below here. Okay. Okay. For this part, I need to compare the p-value I obtained on part B. P-value is 0.010, and I need to compare versus the significance level, which is given in the problem here, 0.10, and we can tell here that the p-value is less than the significance level. So in this situation right here, the p-value is less than the significance level. So we reject the null hypothesis. And having these two parts, the claim does not contain equality. Notice here the claim does not contain equality. Sometimes the claim is here on the alternative hypothesis. Sometimes the claim is on the null hypothesis. So the claim does not contain equality, and we reject the null hypothesis. Is this part, is this case. Okay, it says original claim does not include equality, and you reject the null hypothesis. So this is the way we word the final conclusion. Okay, so we reject the null hypothesis. There is sufficient evidence to support the claim that, well, the claim in this particular situation is that P is different than 0.549. Okay, so we have this as our answer, and that's how you do problem number 9.